Okay, this is the last day of PASS Summit, and I'm sorry to inform you that, but it's true. So, my name is Roberto Fonseca, and I am member of PASS board. I am working with PASS for so many years, and it's a pleasure to be here at my 8th PASS Summit. For anyone working in business intelligence and analytics, your world is changing rapidly. Traditional reporting and dashboards have become standard tools for business, resulting in enterprise looking for your data elsewhere. Data science and AI capture headlines, but there's a lot of important work still ahead for the analysts, if they can keep up with some significant trends. With that, I'm honored to introduce Mr. Donald Farmer, an accomplished author, blogger, and principal of Three Hive Strategy. Please, come on, Mr. Donald.
Thank you very much.
Thank you.
Great, are we wired up? So this is good. I'm going to start my presentation actually by making an edit because I realized I put the wrong Twitter handle here. I don't know who I am. There we go, that's better. Just in case any of you want to tweet. So great, thank you, Roberto. I was working out, this is my 12th PASS Summit, 13th PASS Summit. Unlucky for some. But I have a 9-year gap in the middle. This is about 9 years since I've been at PASS. It's just great to be back here. I always really enjoyed this community and the conferences that we had. So today I'm talking about the new analyst, this person who has to live in the rapidly changing, rather confusing world of business intelligence, analytics, even data science, artificial intelligence these days. And what I want to sort of tell you about are some of the skills, some of the experiences that these new analysts need to have in order to be successful. And in some ways, this is not a technical presentation. In other ways, we're going to be talking a lot about data in a way that I think most of us know is important, but we don't give enough time to it. But my first kind of point I think I want to say is who am I and why is a Tree Hive strategy? This is the Tree Hive, where I spend my afternoons, which is why you can't get me after 2 o'clock. I worked at Microsoft for about 10 years, worked on SQL Server, worked on integration services, analysis services, SQL Server data mining, which was the first predictive analytics product to be built into a shipping database. Worked on Power Pivot, what I guess ultimately became Power BI. And all of these things I kind of build version 1. I'm not really a version 2 guy, so I build all these things, move from team to team, and then moved to Click Technologies, built their new product there called ClickSense, and then left and became independent. And now I work all around the world. I'm going to Europe next week to 4 countries. I'll be in South Africa in March. I spent a lot of time in Asia, a lot of time in Australia, New Zealand. And my work is mostly advising enterprises on data and analytics strategy. I advise software vendors on how to build data and analytics tools for you to use. And I advise investors on how to make money out of all that. And I do most of that. It's pretty interesting work. But I'm based here in Seattle. The Treehouse is, my thinking space where I go and do my best work. And that's really kind of the background to who I am and why I'm making this presentation. So who is the new analyst that we're talking about? The title of this presentation is The New Analyst. Who is that? Well, here she is. And it's really funny that I love stock photography. Stock photography is what's the word? Unintentionally revealing. I mean, it's really corny. And if you really want to know what other people think of your job, just kind of Google for the stock photography. Take off safe search, it's even more fun. And see what actually comes up. And then you'll start to get images of what people think you do in your life. But the great thing about this is actually very telling. I use this picture not just as a random stock photograph. She has a high-powered, top-of-the-line Mac. She also has a Rolodex. And in the same photograph. But that is actually the analyst's world. Analysts may well be working with the latest technologies, and they may well have a Rolodex where all the important information is actually kept. But the other thing that's important about this is about 10 years ago when I was last at the past summit, if I had talked about doing data analysis on a Mac, I'd have been talking to a tiny audience. And nowadays, you go to an event, maybe not to the past event, but you go to any of the events in Silicon Valley, you go to any of the big data events, you go to any of the open source events, most of the people are sitting there using Macs. There are Macs in the front row. There's a Mac and there's a Surface in the front row. That is very telling. That tells you something not only about how technology has changed, that it's now moved off platform onto the cloud, that we're now using more open source, but it also tells you something about the roles that have changed. Because now to be a data analyst is actually to be precisely the type of technical, professional, creative that at one time were the graphic designers, the artists who were the classic Mac users. Now to be working with data is to be in a creative profession. So this is not just a random photograph I grabbed off the web, or if it is, I've done a very good job of pretending it's not. But it is, to my mind, kind of significant that the analyst now lives in this new world. The analyst has 4 attributes, I think, that they bring to their work. They have skills. The data analyst knows what they're doing. They really understand the business. They understand their data. They have tools of choice. They have their own tools. And very importantly, they have tools which are specific to their task. If they're doing data visualization, if they're doing data mining, if they're doing predictive analytics, they have tools specially for that. They're not just grabbing from a kind of a platform. They have access. They can get the data. And they have ownership. They may not have mission-critical work in the sense that if the analyst stops analyzing, the company doesn't stop manufacturing or the retailer doesn't stop selling, but they have ownership of a very important area of what's going on. But underlying all of that is that they have skills, tools, access, and ownership informally. Increasingly, they don't have well-defined structures around these things. The skills they have, a typical data analyst in an organization today may not have done 4 years of study of computer science or of machine learning or of artificial intelligence. They may well have done some EDX courses, some Coursera. They may well have picked up a lot of technical knowledge on the way. They may even have been trained very thoroughly as a DBA or as a database developer or as an app developer. But they're not necessarily thoroughly trained in data, but that doesn't mean they don't have mad skills when it comes to working in their field. They've acquired those skills informally rather than having them achieve them in a structured way. And they have tools informally. And what I mean by that, Gartner once was talking about the rise of self-service business intelligence, and they said, yeah, people are adopting these tools, like Power BI and Qlik and Tableau. They're adopting these tools with or without IT's permission, which is pretty scary. But what it means is if you've got, say, business objects, or you have Oracle BI as your corporate standard, but you really like the visualizations you get from Tableau, or you really like the ease of use of Power BI, or you really like the desktop analytic power of Qlik, and that's what you need to do your job, then you'll go get those tools. And you'll get those tools not by going through a formal procurement channel. You'll probably just use maybe your expenses or even your personal expenses, and you'll go on the web and you'll just download it. How many of you here use Dropbox or Box or something to store business information? How many of you actually get your subscriptions paid by your company? Yeah, like 2 hands. That's what happens. We select tools that do the job, and we go around informally. We're not bad people. We're not trying to break IT or anything. We're just doing our job. But these informal arrangements tend to work. We have access informally. And what I mean by that is we don't hack into systems. What I mean is that the data is there, but we're not necessarily part of an enrolled data governance system, which doesn't mean that governance doesn't happen. It means, I was just talking to Grant earlier about that, it means that IT have a different view of you, that rather than seeing themselves as gatekeepers of the data, they see themselves as shopkeepers who are making data available to people. And this can be informal, but that doesn't necessarily mean it's ungoverned. We've come a long way from, I remember when I was at Microsoft, probably in 2008, the financial crisis was on, everything was chaos. And I visited a brokerage on the East Coast in Connecticut. Big bond, one of the largest bond traders in the world at that time. And everything was kind of chaos, and people were accessing data. And their question was, at that time, Per Pivot was just coming out. And it seemed like the perfect tool. We can analyze millions of rows of data in Excel, which is what they use all the time. So we were chatting with some of the analysts there, and they said, yeah, well, we get all our data from these CSV files. And the CSV files were in a folder, and the folder was called like server name /path/ cappuccino. I said, that's a really weird name for a folder. Why is it called cappuccino? And the girl said, well, that's because every time a new file lands, I have to buy the administrator a cappuccino. And it just kind of reminds me, I get a notification from Cappuccino, I buy him a cappuccino, and I've got some new data. That's pretty informal form of data governance, probably more informal than we have nowadays. But still, the model is still that, rather than the formalized paths of data access that we used to have. There's much more informal ways of getting the data, and they get the data. And then the ownership is also informal. And what that comes back to is what I mean by being not mission critical. It's still important that the analysis gets done, but the company doesn't break if it doesn't get done. But that doesn't mean that you don't have responsibility. You don't have the burden of ownership of that. So that's the new analyst. They have informal skills, tools, access, and ownership. And what I'm really interested in today is, okay, what are the skills? What are the informal skills they must have in order to make that work? And there's a wide range of these informal skills. And I'm just going to concentrate on a few of them and drill in. And by skills, I'm not talking here about the technical skills. I'm talking about human skills, which are very related to the data. The first one I want to tell you is the skill of browsing. And I'll just make this statement straightforwardly. Browsing is more insightful than querying. And I mean this very, very specifically and quite literally, that browsing is more insightful than querying. We'll get into why that is in a minute. By browsing, I mean a different kind of attitude to your data. Designers sometimes talk about the difference between a lean forward and a lean back experience. If you have Steve Jobs here is leaning back with the iPad at the launch of the first iPad. He's literally sitting in a comfortable chair, leaning back. And that experience encourages browsing. That experience encourages an exploration. It encourages an informal engagement with the data. And as soon as you put a keyboard, you can do this especially if you've got a Surface or you've got an iPad with an attachable keyboard. As soon as you attach a keyboard, literally your physical position changes. You're now leaning forward, not leaning back. And that physical change changes psychologically your attitude to the data. But you're also much more focused, you're much more directed. You're now doing a task. You're not just browsing. You're not just browsing informally. And that brings a whole different attitude to what it is that you're doing. I worked with I'm not sure how you call it, like a mortgage, a kind of mortgage broker, a mortgage shop in the Netherlands for a while in one project. And Netherlands is interesting, it's a small country, quite a large population, very homogenous in the sense that it's a small country. So it's not as if there's poor areas of the Netherlands and rich areas of the Netherlands. So macroeconomics are pretty much the same over the whole country. And this mortgage brokerage had stores and shops in different parts of the country. And you could go in and you had a desktop application on a laptop. You could sit with a mortgage broker and you could go through details of the kind of loans, car loans, mortgages, things like that, business loans that you might want. And you could do all the usual things. You could browse by deposits and by interest rates and by all the different terms and conditions. And you could choose a loan. And what they were really interested in was what they called a conversion rate. Does somebody come into the store and take a loan before they leave the store? If they take a loan, if they don't take a loan, they go away and think about it. That's not so good because they might go somewhere else. So you want to convert them in the store. And so they loved this laptop application. People would come in and work on it, and they could make decisions. we introduced an iPad application, an iPad version of the same application. And what was interesting with the iPad version of the same application, we couldn't roll it out to every store at once. So we had a really nice A/B testing. Some stores had them, some stores didn't. And for the period of 6 months that we rolled it out, we found that the stores that had iPads actually increased their conversion rate by 30%, even though it was the same application that was running. It was just running in a kind of iPad version of it. So what would the difference be? And we had to drill into this and do some user experience research to understand this. But the difference is that people explored. They browsed on the iPad. With the desktop, with the laptop, they had to focus. Is what am I looking for? What is a specific thing I want? And what's really interesting with the iPad is that they lean back and they browse. And that actually gives them more confidence. Not just because they find what they want, but they see a whole lot of stuff that they don't want. If you ask for a query back from a database, you get what you ask for. You don't see what you didn't ask for. And therefore, you have to be really sure that what you asked for is the right thing. But now you've just excluded this whole space of things that you're only marginally interested in, that might actually contain information that's very useful to you that you're not seeing. And this is why browsing is so much more effective than querying, because querying, you only get what you ask for. I mean, I can remember Alta, Vista, and Lycos. I'm sure there's a few of us here who can, and there's probably some of you thinking, what? What is Alta Vista? Is that not somewhere in California that's on fire? Well, actually, no, it's a search engine. And Lycos was a search engine. And back in those days, you had fairly clunky search interfaces. In fact, it was like writing a query. You had to use and, or, plus, minus, inverted commas. You had to, use parentheses. You were basically constructed a query language in order to get information back. And then along came Google, and they had a completely different idea. They just enter anything. Now, you can actually still use all the operators with Google. There's a page you can go to. You can go to Google Advanced Search, and you can find all these operators. But who uses them? Nobody. Nobody cares. They're there for, I guess, for people who've got very specific things to do. The great thing about Google and other search engines, and nowadays there's all sorts of search engines. I use one called Ecosia. There's another one called DuckDuckGo. There's Bing, of course, which is very, very powerful search engine. Yahoo's still around. All of these search engines do three things. The first thing is they return vastly more information than you were looking for. You ask for, I like the one, search for, what's this one here? Hotels in Anaheim. I get 60,900,000 hits back when I look for hotels in Anaheim. That's near Disneyland. That is more information than I could possibly handle. And even if I look for something very obscure, like favorite jokes by Ludwig Wittgenstein, I get 81,500 hits back, which is still more pages than I could possibly look at. So I'm getting more information than I could possibly handle. This is the very opposite of querying, where you actually want to reduce the information and get back only what you're looking for. It gives you too much. But the other thing it does is it gives you it really, really quickly. It took less than a second, half a second, in fact, to get 60,900,000 results back. It took 0.37 seconds to come back with the hits about Wittgenstein. So it's really, really fast, and that's a clue to the third thing that it does, which is it enables you to browse. You can search through these results, you can page through them, you can look at them in different orders, you can experiment with them, and very importantly, you can just browse through them and catch a glimpse, we'll come back to this later, catch a glimpse of what's interesting to you. And I look at the hotels in Anaheim, and I can see some have got a star rating, some of them are just clearly commercials that have been placed there. I look at the jokes by Wittgenstein, and I can see that actually, there's things highlighted there that enable me to pick out which one would be interesting. Philosophy and humor, that's kind of funny. Or Wittgenstein means by grammatical jokes, that sounds more technical, and that's not what I meant. And I can immediately kind of browse through these things and pick up the little signals that tell me whether this is something I'm going to be interested in or not. And this is super important. We call that information scent. And the search engines are great at giving you information scent. This browsing is far more effective at finding information than querying, than asking for something very specific. Because if I asked for jokes by Wittgenstein, I might not realize that he actually did write about grammatical jokes. I was just looking for like a limerick or something, but no, he actually wrote some philosophy about jokes. I might not have discovered that if I'd been querying, but by browsing I can discover it. That's actually super important, this ability of the analyst to browse. The other thing the analyst can do while they browse is we categorize. So what have we got on screen here? We've got some dogs. We have some black and white animals. We have some farm animals. And we have all sorts of overlaps in there. We could decide to categorize this in many different ways. And again, we decide to categorize it informally. You just choose, and you say, oh, that's what I'm looking for. People often say that to perceive is to categorize. To see something is to put it in a category, to give something a name. I used to, you come in here, we all sit in the chairs. We immediately recognize them as things for sitting on. They may not look exactly like any other chair we've ever seen, but we categorize them immediately. Nobody's sitting on the tables, for example. I used to work for a Swedish company where that decision was sometimes a little bit more difficult. I actually spent 30 minutes interviewing a candidate for a very senior position, not realizing I was actually sitting on the coffee table. And he thought I was just like the weirdest interviewer he'd ever had. He took the job, that's why I know that, I discovered later on. But anyway, so, categorization is something we do. But categorization is informal. How do you know all the possible categories? There's a great book by George Lakoff, and this title comes from the way in which people categorize things. There's a language in which different, it's an Aboriginal language in Australia, and different objects fall into different categories. And the title of his book comes from one of those categories because there's a category in their language which covers woman, fire, and dangerous things. And all of these things are kind of lumped together in that language. They all have like the same case structure or the same adjectival structure. And this happens again and again in languages. We have different categories of things. But that categorization is informal, and it's dynamic, and it changes. And it's not something that we do with structure. It's something that we just know how that works. The other thing we're really good at doing as natural kind of analysts is we can find patterns. If I was to, let's say I gave you the data for the right-hand side, the chart on the right-hand side, and I gave it to you in an Excel spreadsheet, and I said, I think there's some outliers. Could you find them in Excel? You could kind of sort it, and you would find the outlier, couldn't you? You could probably draw a chart, but without drawing a chart, I think you could sort it and find that weird outlier that's sitting there. If I gave it to you as a chart, there's no problem, just circle it. If I gave you the data on the left-hand side and said, can you do this in Excel? That's much more difficult. I said, I think there's some patterns here. Can you find them? Probably pretty difficult to do. Even when I was running the data mining team at Microsoft, I probably couldn't have done that. I had people who could do it, but I certainly couldn't do it myself. But on the other hand, if I gave this to my 90-year-old mother and gave her a marker and said, can you find some groups there? She could probably circle them with a marker and find them. We're really good at understanding data when it's in the format that works with our human capabilities. Provided in the wrong format, and everybody's stumped, even technical experts wouldn't be able to do it. If I give you this data with the wrong tool, you can do nothing with it. I give you data with the right tool, and you can find something. So you got to match the tool to the capabilities, but the capabilities are there. So what are these experiences that we need in order to help analysts do their work, in order to unleash these natural, informal analytic skills that we all have? I'm going to suggest to you something kind of important, which is that there's one underlying pattern behind analytics, which I'm going to be honest, not a lot of people know about this pattern, but I use this all the time. And every time I talk about this with designers or with analysts or with people who are building products or people who are using products, it sort of resonates. And it's not original. It comes from work that Marcia Bates did in library science. And Marcia Bates was facing the original big data problem. And the original big data problem is really enormously difficult. And it came about because people had microfilm and people had microfiche. And if you've ever used microfilm or microfiche in a library, there you have more data than you could possibly handle. You have entire volumes of books on a film strip. You have entire newspaper on a little microfiche. It's an enormous amount of information in a very, very small format. And the challenge that Marcia Bates and other librarians faced was, how do people find things in this vast amount of information. If you've ever done work in a newspaper and you go to their old microfiche archive, trying to find something there were people who knew how to do it, but it was very difficult to do that. And what she said was that, well, this browsing experience, this experience of trying to find things in a library or in any information system, and that's what analysts are doing, they're working with an information system, falls into these 4 experiences. And I've kind of taken this and applied it more in our modern information system. So I've kind of updated it for data and analytics. The terms aren't exactly what Marcia Bates talks about. And I don't want, as usual, any kind of errors, anything that's wrong with this emerges from my work, not from hers. But here are the 4 steps: orientation, glimpsing, examining, and acquiring. And we can just go through that and kind of walk through it. And I'll take the library example and then the data example. Think of the library example. This is the beautiful Advocates Library and National Library of Scotland in Edinburgh. How do you find something here? Well, obviously, you can query. There's a catalog, and you issue a query. You can't go to the librarian and say, give me all the books that you have on the history of Edinburgh, because that's probably what you see here. And they can't give you everything. You would need to be very specific. You need to go to the card catalog, and even then, that might not have the metadata that you want to find something. On the other hand, if you can go and browse on the shelves, then you can find stuff. But the first thing you have to be able to do is, am I looking in the right place? Have I oriented myself? Do I know what I'm looking at? And orientation has, I think, really 2 modes of orientation. And I can show you the 2 modes here. Who knows what's going on the left-hand side here? Anybody from London? No? Anybody driven? Anybody been riding in a London cab? Yeah, this is a test. It's called the Knowledge. And if you go to London, you will see guys riding around. They still do it on mopeds. And they're always on mopeds, and they always have this map in front of them. And what they're doing is they are learning every street in London. To become a black cab driver in London, you have to know every street in the entire Greater London area. There's a big kind of circle they put around it. And you have to be able to know your way from any street to another. And the test they will give you is, here's this obscure street, here's this landmark, drive between them. And you have to drive between them. And so they spend years, 3-4 years, driving around on their mopeds, constantly learning every street in London. My father used to be a telegram boy in Glasgow. He knew every street in Glasgow. They didn't have to do it as a test, he just learned that. On the right-hand side, you have probably an Uber driver or somebody just using a GPS, and bang, 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 off they go, and they find their way. And I can find my way around lots of places. I was in Boston recently. I actually don't know Boston very well, but I used to have an office in Newton. I know how to get from central Boston to Newton. I have no idea. I pass things on the way. I kind of vague idea that there's a baseball park called Wrigley Field. I have kind of vague idea that there's a college. But actually, I don't know. I mean, that's it. And but I get on the train, I get off the train, and I've reached my destination. And I can kind of do a couple of other places along the way. So the difference here is the difference between whoops, I fixed that, and it came, that's really, really annoying. Okay, I might need to do another edit, because I thought I fixed this just before I came up on stage. On the left, it's survey knowledge. On the right, this should say route knowledge. In other words, route knowledge is, I know how to get from A and B. I know the specific things I have to do in this information system, and I know how to navigate. Survey knowledge is, I know how it all hangs together. How many of you kind of followed the little arrows in order to get here from across to the conference center? Yeah, you had route knowledge. How many of you could actually go home and draw a map of the Washington State Convention Center even after 4 days? Well, probably not that many of you, because you haven't acquired the survey knowledge of this system. When you think of the information systems that we have in our enterprises, what do you have? Do analysts have survey knowledge or route knowledge? Analysts typically, a business analyst typically has pretty good survey knowledge of how the business works, and pretty good survey knowledge of how the data that relates to her sphere of the business works. When it comes to other things, I think of the sales manager sitting down and pulling up a report. What do they have? They have root knowledge. They don't know how the data works at the back end, but they know how to open the report. They know how to get to their dashboard. Got a question? Yeah. Yeah, that's right, R-O-U-T-E, yeah, sorry, route. They've got route knowledge. I should have done that. So annoyed that I changed this. I just realized that I opened up a recovered version of this rather than the version I changed. But yeah, they've got route knowledge. I should just do that whole last 10 minutes again, right? Do that. So this important difference between do you understand how the system hangs together or do you understand only how to get from A and B? I was talking to some people who got lost recently in the woods in the Pacific Northwest, and my son was one of the people who was on the kind of search party that found them. They weren't lost for very long. They spent the night, but a pretty scary night. Every shadow was a bear and things like that, and they'd never heard coyotes howling, and they were pretty terrified. But anyway, we found them. The problem was they only had route knowledge. They'd been on the hike before. They didn't have survey knowledge. They took a wrong turn. The people who did have survey knowledge found them very quickly. And so when you think of your information systems, what do your analysts have? Do they have survey knowledge or route knowledge around that? When you actually come back to a data system, how do the interfaces that you build, how do the dashboards you build, the reports that you build, how do they give users orientation? How do they tell the user what they're seeing, where they are, and where they might possibly go next? That's a critical element of displaying data and information to people. How do you orient them so they know what they're looking at? So I look at this. This is from Power BI, and it shows me things like I've got the markets portals. I can see business applications. I can see application platform. So I kind of know what I'm looking at. This is from a chart. This is from a blog post where people were explaining how Microsoft used Power BI internally. And I can see a lot of small kind of thumbnail charts, all of which seem to show fairly similar data. And I've got some kind of coloring. And I'm not sure if the coloring means anything. Is it just there because it's a pretty picture? Or does it actually have any significance? How do I find that out? I actually don't know. I can't tell from looking at this. I can't orient myself in this data because I actually don't know what all these colors mean. Do the colors actually just, they seem to align with the stuff at the left, but what does that mean? In some ways, the designer of this has actually done a pretty good job of using some colors and some layering to give some orientation, but maybe they haven't gone far enough in terms of actually enabling you to understand what it is. If I had route knowledge, or route knowledge, I could get in here and probably pick out exactly what it is I'm looking for. If I have survey knowledge, then maybe this makes sense to me as well. But this application itself doesn't really help me as much as the designer probably thinks. It doesn't really help me to orient. A better design would have clearer, better orientation that told you where you are, what you're seeing, and where you could possibly go next would be a very important part of that observation. The second part of this is glimpsing. I mentioned it earlier when we were talking about the little hints, the information sent that you get in searches. And glimpsing is important because this is my bookshelf, and you can see certain things there, okay? You can see some, well, actually immediately you can see a couple of Wiley books, can't you? Anybody who's got a technical bookshelf knows you can see a couple of Wiley books there. You can probably see some that have got SQL. You probably see some that's got SQL and Excel maybe on there. I can see Andy Leonard at the back desperately straining to see if his book's on my bookshelf, but I can tell him that it's actually on my desktop. That's why it's not on the bookshelf there. But this is kind of, it's just easy. You can just glimpse and see what's on my bookshelf here. And if you're looking for a book on SQL or you're looking for a technical book, you can pick out the Wiley technical books really easily. If I had one of these kind of orange and red ones, if I had some O'Reilly books, you would see that very, very easily. This is important because remember that picture of the library with like thousands and millions of books in it? Now, how could you possibly pick out things? Well, there's information sent which comes from the books. You can tell that some of these books are kind of pretty new. They have modern designs. One, The Brain of the Firm on the bottom left-hand side, that's back from the 1980s. So that's really not the 1990s. That's a book on cybernetics, as we used to call it back in those days. Wonderful old word that should be revived. Some of these are very modern books. Some of these are very new. You can sort of tell by the designs. You can tell by the typography. Some of them are attractive. Some of them seem very kind of plain and workmanlike. But there's things there which attract you. You glimpse them. You can't, even in the time that I'm speaking to you here, you can't look through every single one of these titles to work out which ones are interesting. And you go to a library of books, go to the bookshop on the Sky Bridge. You can't look at every one of these books in a reasonable amount of time in order to choose the ones you want. You have to be able to glimpse them to see that information. That's why Google put those little highlights in the search and arrange the search in a particular way, because you can't look at every one of the 81,000 results that come back. You have to have a way of glimpsing what you're interested in. And so information interfaces help you to glimpse. This is a Tableau chart, and I was talking about outliers earlier, and there's glimpsing I can do here. I can absolutely see that there's some coloring here which helps me to identify positive and negatives. There's some outliers, and I can immediately see those outliers. I can kind of hover over and get some detail as well. So I can equivalent maybe of reading a cover. But it's super interesting here that it's glimpsable. And one of the things you have to think in information science and information presentation and in helping your users to navigate through analytic systems is, am I enabling them to glimpse something? Because they can't analyze everything. So how do I help them to glimpse what's important? That comes down to the choice of coloring, the layout, the choice of visualization, all these things important. Here's another one from Yellowfin. Yellowfin actually shows you through these little kind of chevrons, these little flags that they put on the data. Here's something that happened. Here's something where the data dropped off in value on a particular day, or here's a spike, here's a trough in the data. And that's worth drawing attention to. And so I can orient myself here, but more importantly, I can glimpse. I can glimpse, here's something that might be interesting. If I looked at this data and there were no little indicators of spikes or troughs, that's fine. Data's fine, I move on. I don't look at it in great detail. I just move on to the next thing. And I've done my analysis. I've done my job at that point. So glimpsing is very, very important because it makes analytics efficient. But once you've glimpsed something, now you need to do something more. You need to understand what it is. And so next step of glimpsing is examining. Well, here's a book that I think I might be interested in. Here's the one that seems to be attractive, that seems to have the information I want. But now I need to make sure. And so I might sit down, I might take the book out, I might browse through it, I might look at the photographs, I might look at the reviews on the cover, I might look at the index, the chapter headings, and those things. I don't read the whole book. That's for later. But I examine it to see if it's interesting and important to me. And then once I've examined it, then I can go on and do something else. And again, in data, you want to examine. This is an example from Click, where I can take a value, I can select it, I can see through a kind of what the engine gives me, the ability to see the selections I've made, shows me data as part of my selection. All the charts change to reflect this selection I've made. And now, having glimpsed something, I'm now examining it in more detail. And I'm saying, yeah, this crazy outlier, what's going on there? And now I'm examining. And so I've oriented myself in the system. I know what I'm looking at. I glimpse something interesting, and now I examine it. And then the next step beyond that is acquiring it. And this might seem like a strange thing to talk about in the world of data, but what I mean by acquiring it is that you do something with it. Having made your observation, having made your discovery, having analyzed something, now you've got to do something with it. On my website, I've got this kind of catchphrase that I use, and it says that data without analytics is a wasted resource, but analytics without action is a wasted effort. You actually need to be able to do something with what you analyze in order to get business value out of it. Now, acquiring in the library context is fine. You check out the book. That's that. You've acquired it. Now you can go away and do something with it. Acquiring in the data context is something a little bit different. Here, for example, we have Power BI integrated with Teams. And Teams is a collaboration infrastructure, so once I've found something in Power BI, I can share it with other people in my team. And I can have a conversation about it. I can collaborate. We'll talk about collaboration later. Here's an example from Domo. And Domo have this on the right-hand side, what they call the buzz, which is like a conversation channel. It's a bit like a kind of Slack channel built in directly to Domo, or it's a bit like Messenger, somewhere between Messenger, Teams, Slack, but it's very specific to the data. And if I actually click on one of these conversations, the data that I see on the charts on the left-hand side will change according to where I am in the conversation. So I can relate the conversation back to the data at the point that somebody actually made the comment. And so it's kind of deeply integrated collaboration. But it means when I've acquired something, and I put it on this conversation board, and people start having a conversation about it, I have context. So having oriented myself, having glimpsed something interesting, having examined it to see that it is interesting, I can now acquire it and do something with it. I can start to take action. And that's the kind of final part of the analytic process. So what I kind of say for the new analyst is, it's useful if they understand that process. Even if they don't necessarily understand or acknowledge that process, it is going on in the background. And if you have a knowledge and understanding of it, you can help the analyst considerably by designing to these capabilities. Please. Yeah.
One of my concerns is perceptive bias. And what I mean by that is how the skills or lack thereof of the people who are developing the visualization environments are directing outcome. They're directing and wiring.
So that's a great question, that the problem of bias, that people who are building the visualizations, creating, maybe even delivering the data, are somehow inherently providing bias, in which case this process may actually be flawed. There are good questions that you get from the audience. There are great questions. The great question is when the answer is on the next slide, and that was a great question. Because just about the rest of the presentation is all about bias. Before getting to bias, I'm actually going to talk about ambiguity. I had a friend who was once, he had a great title. His job was the McKellen Professor of Vagueness and Ambiguity at the University of St. Andrews, because ambiguity turns out to be a really interesting subject in philosophy. He once got a speeding ticket and had to appear before the judge, what we call a sheriff in Scotland. And he appeared before the judge, and he's kind of asked to give his name and job, and he says, I'm the McKesson Professor of Vagueness and Ambiguity. And the judge kind of held his head in his hands and said, this is going to be a long day, isn't it? And it was, and he got off with it. Please. Right, yeah. So you've worked very specifically in some areas. You've worked with data mining, and you're concerned that there may be, in the data, there may be statistical features that a self-service user doesn't understand. Well, somebody's going to show, yeah, so somebody could make an interpretation that actually isn't statistically correct. I love it. That's the next again section, but we'll absolutely get to it. Yeah, totally. So at least I've got one person who's going to stay to the end. Great, okay. So ambiguity, vagueness and ambiguity. So in 2016, there was this big storm off the coast of Seattle. This major windstorm was coming in on October 14th, just just about last month, 3 years ago. And here were the headlines in the newspaper. The murderous Columbus Day storm was like this. And you can imagine, our local store ran out of kind of candles and things like that, which was bad when you're a hippie. People were buying up like all the tinned food and stuff like this. They canceled school dances. That's how critical it was. This major windstorm, tornadoes, and much more. I mean, how much more dramatic could you get? And then it gets to the kind of today's major storm. It's a difficult forecast. Well, they weren't saying that when it was the murderous storm of '62 or canceling school dances. And then a deeper look at Saturday's storm. Can we do better? And the storm that wasn't, why they got it wrong. And what was interesting about this is that Cliff Mass, our local weather forecaster here, who's so kind of famous in Seattle, says, I think very perceptively, he says, my profession needs to work hard to find better approaches for communicating uncertainty, methods that will be effective in the age of social media. Now, why is the bit at the bottom important? Well, because there's lots of uncertainty in the forecast. Cliff Mass and other forecasters actually were saying, yes, you have to be aware that there's a major storm that might hit, but you know, if it does hit 30 miles down the coast from where we expect and it blows out in the mountains, things might be okay. But nobody heard that bit. Nobody tweeted about that. Nobody updated Facebook saying, yeah, it's probably going to be all right. There's a 30% chance we'll be fine. What they tweeted about was the disastrous consequences that are bound to happen. And of course, the social media then retweets that, and it gets more and more kind of exaggerated. And before you know, the whole it blows up. And the ambiguity, the 30% chance that this other thing might happen, that didn't come to pass. The 70% chance didn't come to pass. The 30% that people forgot about, that came to pass, which was turned out to be absolutely okay. And so the problem here was that the bias crept in, not in the analysis of the data, which was perfectly okay. In many ways, the weather forecasters were right in their prediction. There was a 30% chance that it would be okay, and it was okay. But nobody listened to that because our emotional biases gear us towards the dramatic story. This was not, by the way, the only major prediction that people got wrong in 2016. And I really, this example is kind of hilarious to me. Nate Silver, this great kind of psephologist who's supposed to have all the understanding, he's predicting final election update, wide range of outcomes, most of them come up Clinton. The next day, why 538 gave Trump a better chance than almost anyone else. Do you know what better chance they gave? They said a 28% chance as opposed to an average of a 22% chance. And Nate Silver is saying, yes, but we were right. There was a 28% chance, and it happened. If you did run the election 4 times, 5 times, then Clinton would have got elected 4 times out of 5. But that's not what happened in the real world, because the real world, well, actually, funnily enough, the real world in our case is artificial, because we only run elections once, and the outcome is artificially binary. Or if you like, when I say artificial, I don't mean fake. I mean, it is determined to be binary. We decide in advance that it's binary. That's how we play the rules, just like a tennis match or a baseball match where somebody always wins. It doesn't go to a draw, except in very rare circumstances. In tennis matches, somebody always wins. There's no draws. While in cricket, you can play for 4 days and then still decide that nobody's won, which is great. It makes for the best games. But there's an outcome here which must happen. And therefore, all the statistical randomness around about it really doesn't count for anything if the 28% chance comes out. And this is very important. We don't understand these ambiguities very well. Berwood Yost, who actually ran one of the other polls, said the incentives now favor offering a single number that looks similar, and certainty is rewarded. I guarantee you go back and sit in a quarterly sales meeting and talk about sales projections and think about this quote, and what you're hearing is certainty being rewarded and numbers that sound very like what everybody else is saying with certainty. And that's not statistically realistic for how the world works. J.M. Coetzee, an author, actually put this really well. He says, if you don't already think in probabilistic terms, predictions seem vacuous. I mean, what I mean by that is that being bold, being precise, being confident, and giving what seems like a very clear answer sounds much more convincing than somebody trying to tell you about vagueness and ambiguity. General MacArthur didn't sail away from Manila saying, I'll probably be back. Maybe it's kind of on the balance of probabilities, I'm likely going to be back here in a few years. That's not a world-shaking kind of confidence-giving prediction. I'll be back is. And so vagueness and probability, actually, although they can be accurate, although they can be insightful, although they can be true, are also not as convincing. We do this all the time. I was talking about sales pipelines. In business, we build these pipelines where we have, pre-qualified, qualified customers, we have prospects, and we're trying to understand sales. And our normal way in business intelligence of understanding probability and of understanding prediction, of understanding ambiguity, is just to throw more data at the problem. Let's just create more visualizations of more pipelines. And then you end up with situations like this, the sales funnel. And so we can predict sales for the next quarter of, well, what's the number there? $7,493,087.68. That's a convincing prediction. It's right down to 68 cents, And then we give kind of vague numbers around about that. And I look at sales charts like this and I say, why don't they just say $7.5 million? Any business decision you're going to make can be made as easily knowing it's $7.5 million as it could be made knowing it's $7,493,087.68. Nobody's going to make a decision that affects that sales pipeline that needs that degree of accuracy, but we throw it in because it looks convincing. It's the fallacy of false accuracy. And this is just a pathetic way to deal with the ambiguities of business. How could we do better? Well, if you talk to a data scientist, maybe we talk to you, and you would say, oh yeah, well, we need the error bars and we need the error charts. And that's fine if you have that expert knowledge. In fact, if you have that expert knowledge, it can be extremely useful. Trouble is, not everybody's an expert, and not everybody understands. My father was an engineer, and very interested in all sorts of statistics and data and things like that. Did a lot of work on mean time between failure analysis. And he was diagnosed with a form of motor neuron disease. We thought he had Parkinson's, but diagnosed with a form of motor neuron disease. And it's kind of distressing. My sister was with him, and the doctor said, this problem with this is, Parkinson's, you can live a long time. Typically, pneumonia might get you in the end. But motor neuron disease is a degenerative condition. You will die from this. And the average survival rate from now is about 3 years. And my father gets very upset. Not at the prognosis of 3 years. He got upset because the doctor couldn't tell him what the median survival rate was. Because what he wanted to know is, what's the distribution here, man? It took the doctor 3 months to come back and tell him what the median survival rate. 11 years later, my father died, satisfied with his life and doubly satisfied that he was an outlier. But we use these statistics all the time in our life, and we don't, we just kind of these hopelessly, approach to statistical knowledge. Population projections. We show this chart. This comes from this was the World Bank. I think this was the World Bank. And they give these population projections. These population projections actually came from an academic called Roman Flaherty in Seattle. And he doesn't show his data this way. He shows his data this way. That's the same projection. That looks like you know what you're talking about. That also, and this is a beautiful visualization. You know what you're talking about, but look at how he's visualized the ambiguity. And now you can actually have a much more informed conversation about whether actually is it Africa or Asia. What are the scenarios that are going to play out? What are the likelihood of these things? Now, if I saw sales projections with the same type of ambiguity, the same sort of knowledge, and you don't need to be an expert to understand this. This is beautifully visualized in such a way that anyone could actually understand this. You don't need to be a specialist to dig into this, and you don't need to be a specialist to have the extra conversations. And then back to the weather. This is how we actually do our weather predictions. So if you're going to have a barbecue at the weekend, this is what you might look up. You might go on the Weather Channel. You would see this. Does this actually help you? Well, there's a 10% chance of rain. There's 10%, it's sunny. Friday, there's showers in the morning. But what you don't know is, what's that rain going to be like? If it's 10% chance of rain, what they actually mean is a torrential downpour at 2 p.m. in the afternoon, right in the middle of your barbecue, then that's going to ruin your barbecue. If they actually mean that it's 10% chance and it's Seattle, so it's going to be drizzling all day long and you can kind of go into the carport and have it there, then probably that's okay. But it's not really telling you that. These numbers look as if they're giving you information. But how do you interpret it? We have no context. They have no context for how we're going to use the information, and we have no context for how they're presenting it to us. It's not matched to our needs, and we don't know what the assumptions that they're making about what we're doing. In Britain, when I lived in Britain, I used to get up very early in the morning, still do. But what I used to listen to early in the morning were the weather forecasts, not the weather forecast. There was a weather forecast for the country. There was weather forecast for fishing, the shipping forecast, and there was a weather forecast for farmers, because all of them need different forecasts. And living in the Scottish Highlands, we got the mountain forecast, because you also need a special forecast if you're going to be out in the mountains, which is different from the general forecast. So the BBC spent about 20 minutes in the morning giving you 4 weather forecasts targeted towards different functions. And you go on AccuWeather, and what you get is something that's vague and general. And even if it's accurate, at the same time tells you nothing. Doesn't enable you to take action in the way that perhaps it could. This is a slightly different one. This is a severe warning forecast. And I like this one because even without looking at the right-hand side, which I'll tell you about in a moment, the left-hand side tells you, is it going to be a low impact, high impact, is it likely or unlikely? And now you can start to make some decisions. And you say, well, yeah, but what does that actually mean? What does high impact mean? Well, you can click, and the right-hand side shows you what you drill through to, and this is for snow. And if it's very low impact, it means a few transport routes are affected. And a very high impact would include things like rural communities are cut off for a prolonged period. And so given the kind of sliding axes of 4 scales, and given the kind of likelihood, you can start to decide whether this would be significant or not. So there's a likely impact in this case that transport routes and travel services are affected, and your journey time is going to be longer, and there'll be some stranded vehicles, and there'll be interruption to some power supplies, and some rural communities may be temporarily cut off due to snowdrifts. And now I can make my decision about whether I'm going to visit my sister in the Highlands or not. And that was an easy one. And that's the sort of information that's actionable. And this is actually a much better way, if you like, of showing the vagueness and ambiguity around that. And this is important because, you know, weather affects us all. The cone of uncertainty that you all see in these hurricane forecasts, the reason that's such a problem is that some people look at that who are not data specialists and not data literate in the way that you guys are, and they look at that and they interpret that as the storm is getting bigger and bigger and bigger as it goes north. They don't know that that means the storm could be anywhere in that space. What they think it means is the storm will be covering, you know, the whole of Georgia, or you know, take your Sharpie, make it a bit bigger. But they don't actually know that this is showing ambiguity. They think it's showing accuracy because it's there, it's in the New York Times. And then some of you may have heard of this guy, Edward Deming. Without data, you're just another person with an opinion. And his idea, a great statistician, and his idea is that data gives you insight. And if you've just got opinions, bring the data to me. In fact, I have an alternative to this statement, though, because I don't think he's wrong, but I just have a little twist on it, which is, even with data, you're just another person with an opinion and data. Don't think you don't have opinions just because you've got data. You are just as opinionated if you've got data. He also said, in God we trust, all others must bring data, which is a very funny, kind of clever saying, but he's almost suggesting that there's some magical property of having data that somehow cuts through all biases and cuts through all our statistical kind of lack of knowledge. You can understand things if you have data. I think it's very dangerous to assume that somehow data has this magic property of being perfectly understandable, because it simply doesn't. We think of ourselves as being logical. We especially in the data business think that we're a bit like Dr. Spock. You know, give us the right data, the right input, we'll make a logical piece of analysis. Let me ask you a question first. Did you enjoy your breakfast this morning? Did you have breakfast this morning? Yeah. Did you enjoy your breakfast? Who enjoyed the breakfast? There you go. Great. Good. So I ask this question because Anthony Dayton, who used to work with me at Click, and I ran an experiment on Mechanical Turk. You know, the Amazon thing where you can post up questions and people answer them online and you pay them like a cent. And we asked them the question, did you enjoy your breakfast this morning? So why would we ask that question on Mechanical Turk? Well, it turned out that there were 3 groups of people. Some people just got the question, and 2 other groups of people got the question with 2 photographs. And here's the 2 photographs. A guy looking very seasick in Boston Harbor. Did you enjoy your breakfast this morning? And you have to look at this guy while you answer. And the other of the kind of happy smiling girl, white teeth. Did you enjoy your breakfast this morning? And here's a funny thing. Well, actually, you know what the answer is already. There's a statistically significant difference here. More people didn't enjoy their breakfast when they're answering the question looking at the guy who looks miserable and seasick. And more people said they did enjoy their breakfast when they saw the picture of the happy smiling girl. And the holdout group was kind of, you know, managed to prove that difference. This is ridiculous. You either enjoyed your breakfast or you didn't. How can it be affected retrospectively by the photograph you're looking at when you answer the question? This is bizarre. And yet, this is human beings. This is how we work. This is how our mind works. This is how our logic works. And I don't think it makes any difference if you're a statistician. You can be trained and you still fall for it. They did an experiment with judges in Germany. And judges are trained in making rational sentencing decisions. And they gave judges a set of cases to look at, which had to do with what you might call moral crimes, prostitution, stuff like that. And they were asked to pass sentence on these example cases. And some of the judges, while they did this, sat in a room, which was just a kind of gray room, and others sat in a room which was the same room, but it had pictures of graveyards and churches and things. And the others sat in a room, which is the same room, but now it was decorated with fluffy kittens and bunnies and spring flowers. And yeah, you know what happened. The people the judges, the trained judges, trained to be objective, sitting in the room with the features of death and morality around them, gave sentences that were astonishingly 8 times higher than the judges who had the fluffy bunnies and the kittens surrounding them. This is ridiculous. This is people who are trained to make those decisions. Tells you what kind of t-shirt to wear if you're ever up before the judge in Germany, but that's important. And these emotional biases. We think, oh yeah, sure. You go and search for the Cognitive Bias Codex, you'll see hundreds of cognitive biases. How could we possibly allow for all these? I think it's really difficult. I think it's really difficult to look at all these cognitive biases and say, I've dealt with every single one of them, or I've identified them. What most people do is they learn 5 or 6 and then think they've got it covered. But the truth is human beings are enormously complex. But there is one, this came from Michael Lewis of Moneyball. I think there's one way to think about this which helps you to cut through it. Michael Lewis said, an explanation is where the mind comes to rest. That explains it. I can rest now. And the question you have to ask yourself again and again is, why does my mind come to rest there? And the statisticians will say, because I followed the data. But have they really? Why? Another statistician might find something else. The big question is to ask yourself, and it's an internal question, why do I come to rest there when other people don't? Let me give you an example. This is the murder rate in Scotland from 1957 to 1968. To be really clear, we're talking about 100 murders. I literally couldn't fit the US murder rate on here, even if I did it by percentage on the same chart. But still, this is the capital murder rate, and that you could get hanged for. This is the non-capital murder rate, and it's a total. And if you look at 1965, you can see the data actually starts to take a spike after 1965. And what happens in 1965 is that capital punishment is actually abolished. There's no more hanging. And the murder rate goes up. Now, if you're a typical kind of hang 'em, flog 'em kind of conservative who wants to kind of say, no punishment is too good for them or too bad for them, then you would take this as absolute evidence that the murder rate was a deterrent. And that you take away, that the capital punishment was a deterrent. You take away capital punishment, and up goes the murder rate. Well, they did it. They actually didn't just take it off the statute books. They actually took it off experimentally for 4 or 5 years to see what happened. And then in 1969, after this chart, they actually decided, yeah, we're going to do away with capital punishment altogether. In other words, they saw the murder rate increasing after they took away capital punishment, but they still took it away permanently. And why? Well, because the data doesn't show you everything. The data isn't as clear as you think. What actually happened was, and the analysis they did, was they went out and got more information. And what they discovered was that prosecutors, prior to 1965, didn't bring the most serious charges because juries didn't like convicting people of murder. Especially men who had been through the war were very reluctant to sentence people to death. And so they found them either not guilty or guilty of lesser crimes. So capital punishment did deter people. It deterred juries from finding people guilty, and therefore it deterred prosecutors from bringing the most serious charges. After 1965, there's no chance of the person being hanged, so you can bring more serious charges. So you'll bring murder, you'll bring, instead of manslaughter, and you'll bring the most serious murder charges rather than a lesser charge. And so now it looks like the murder rate is going up, when in fact what's actually happening is a change in the metadata. It's a metadata function. That's rather interesting. It's the definition. Now, I know what you're thinking. What on earth has this got to do with business? Does anybody remember a company called Sagent? ETL company? They were here in 1999. Nobody was here in 1999? They had a booth here in 1999. They kind of failed almost immediately afterwards. It had nothing to do with PASS. It had to do with an investor who invested in Sagent and then went out and had his other companies that he'd invested in buy products from Sagent. And then so come the end of the quarter, up goes the stock price, lots of great sales. He sells his Sagent stock and then cancels all the orders from his other companies. This worked perfectly for about 6 days until he was caught. But those sales weren't real sales. What's a sale? Is a sale when person signs the paper? Is a sale when the deal is done? When do your salespeople get compensated? Do they actually wait until the money's in the bank? What if it's a 5-year deal, you know? What is a sale? What's the definition of a sale? It's almost like what's the definition of a murder? In the case of Sagent, you know, they thought the case was closed, but the jury hadn't returned a verdict. And that's a real problem. The definition of your data may actually determine the outcome of your data. It's a rather circular kind of conversation, but it's very realistic in business terms. Here's another example, which, I mean, this was probably a controversial one, but you know, here's an even more controversial one. And this is sort of, I use these ones because they're telling, because they're interesting, because you'll remember them more than some kind of bland business example. So they did a survey, and I'll not go through this whole thing. You don't need to read it all. But basically, this survey asked people, did they believe in evolution or not? And it started off with this question: humans have evolved over time, or humans have existed in their present form since the beginning of time. And then after they answered that other question, they asked, had that got to do with God, or was that just natural and it wasn't guided by God? And when you ask the questions in that way, it turns out that 31% of people said humans have always existed in their present form. And 20% said they were guided by God. And 40% said it was natural selection with no God involved. What if you ask the question another way around? What if you ask all three questions and say, was it evolution with no God? Was it guided by God? And was it completely by God with no evolution? Suddenly the numbers are completely different. Now you have 18% of people, not 31%, saying human beings have existed in their present form. Now, what's going on here? How is such a big contrast? Is it that people don't know what they believe? Actually, it's the very opposite. People do know what they believe, and the way you're asking the questions are steering them down a path which they are trying to support their beliefs. If you ask them the first binary choice, and they know God is part of the answer that they believe in, they're going to go towards the question that's more likely to include God. They don't know you're going to take them down a binary tree of decisions later on. They don't know what questions you're going to ask next. So people aren't being naive here, and they're not being stupid, and they're not being, what's the word? You know, they're not trying to game the system. They're just answering the questions the way you ask them. And this is not only true. Any of you who do requirements gathering, any of you who are out there asking customers about their preferences are going to be facing the same problem. You ask about governance and self-service. You ask about, you know, what's the role of governance and ease of use and flexibility and giving users data access. And it all depends what questions you ask first, which path they're going to go down. Yeah.
This is also another concern that I have, that in today's climate of the so-called data scientist and data engineer, I feel like the sociological and behavioral sciences are being left out of it.
Have you seen my deck before? Did you see a preview of my presentation? Because basically I did. I'm kidding, but it's because this is kind of the point I'm trying to get to. This explanation, the explanation is where the mind comes to rest. And that's really important, is why am I satisfied with that explanation? Why would I be satisfied with one explanation of the murder rate when somebody else has got another one? Why would I be satisfied with, let's say I showed you this poll. I showed you that one. We would all go away and have a big debate about what people believed, not realizing that there was another possibility. There was another alternative, which might actually lead to another debate. And if we were statisticians, we would be arguing about these numbers, and we wouldn't actually even know there was another alternative to that. So what do we do about this? And what we do about this is really important. It's about data literacy and collaboration. Well, one thing that Roberto didn't say was that, and I don't say very much when I'm presenting, is when I was in Scotland before I moved to America in 2000, I spent a lot of time in prison. And you don't need to secure your bags. I was a volunteer. And I was working on data literacy projects, not literacy projects, ordinary literacy projects, helping prisoners to read or write. And it turns out that if you are illiterate in our society, you're almost in prison already. Vast majority of prisoners have poor reading and writing skills. They can't get jobs. They can't get housing. They can't, you know, it's almost impossible to function in our society without being literate. I don't do much work in prisons anymore, but I do work with a literacy program in India, known as Pratham, a fantastic nonprofit. 40% of the world's illiterates live in India, and we're trying to address that problem through this nonprofit action. And something's very different there. That's not an individual person who's illiterate in a literate society. What we're trying to do here is make society literate. And that's transformative. Because when an entire society is literate, then you can do things like, there's an outbreak of bird flu, you can give brochures that tell people what to do about it. Society, you can collect taxes, which requires literacy to be able to do that. This is very significant. It's a big difference between a literate individual and a literate society. Data literacy, unfortunately, is something that many people struggle with. I don't know how you would answer this question, but apparently, people had no problem giving their answer. What should cost less? Even when the data is 100% accurate, it might not be as literate as you think. I've always particularly appreciated this visualization. You were asking about sociological, phenomena. I think there's a sociological phenomena there that needs to be investigated. The point about this, and there's a very good reason for my next slide, it is that people ultimately, they don't trust data. Ultimately, we actually trust other people. When we talk about statistics, when we talk about Edwards-Deming and everybody else bring data, actually, it's a human problem. It's about the trust between people. When you give somebody the annual sales report or you give somebody the quarterly business review and it's been carefully sourced, those managers, those executives don't go out and search the metadata of every field to make sure you've done your ETL properly and your aggregations and your calculations. They trust you. If you get it wrong, then they don't trust you anymore. But ultimately, there is not technical trust. It's not technical validation. They're not doing statistical analysis. They're trusting other human beings to get it right. And we can't take that element out of it, even if we wanted to. Collaboration is absolutely critical. This is the price of a commodity on a market on a daily basis. And look at it. The price is all over the place. If you are working in this market, you can't do any arbitrage. You really can't do any planning in this market. You can't do any investment in this market. You have no idea what the price is going to be. It's just going crazy. And this wasn't just one example. This was in 3 different regions. This is actually the price of sardines in fish markets in southern India being paid to subsistence fishermen. And the price is crazy. They have no idea. They have no insight into this. There's no pattern. There's nothing they can do with it. They can't invest. They can't buy a new boat. They can't send their kids to school. They can't get a loan to build their house. Because there's just no predictability in the market whatsoever until cell phones are introduced. And as soon as cell phones are introduced, as soon as they build the cell phone towers, the price almost magically stabilizes. Stabilizes so much that you can actually pick out monsoon season. You can actually see the little spikes for a few months where the price goes up because it's monsoon season and it's difficult to go out and fish. And now they can plan. Now the whole economy is transformed because they can plan, they can invest, others can plan and invest, just because they can speak to other people. They can phone the market 5 miles up the coast and say, what price are you getting? They can phone the restaurant and say, what price are you paying that guy for what he's buying from me? And they can get those prices and then the price stabilizes because of competition, but more importantly, because of collaboration and information. The information flow and the collaboration, the human collaboration, provides a much higher value system than ever happened before. This is why Alan Weber of Fast Company magazine said in the new economy, conversations are the most important form of work. He doesn't mean spend all day chatting around a water cooler. What he means is that it's not the data that matters so much as the conversations you have about it. Everybody can have good data if you put the effort into it. If you check into your hotel and you see, the kind of TripAdvisor score, now every hotel has very complete competitive information about every other hotel in the region. It's what they do with that information that matters, that makes the difference, how they pay attention to it. So this is really important. Data literacy for me isn't personal skill. This is not about whether you are a statistician or whether you've been on an EDX course or whether you understand the ETL process. It's whether as an organization you're collaborating with that knowledge and on that information. So for me, the most critical thing here then is that the analyst, yes, they have the skills and the tools, they have the access, they have the ownership, but they also need these capabilities. They need to be adaptable because the information environment is changing all the time. They need to be aware. They kind of need to be self-aware. They need to understand what they're bringing. They need to understand the biases that they're bringing. They also need to understand, in a sociological sense, as you were saying, the biases that other people are bringing. And not in a judgmental way, but in an open-minded way. Why does their mind come to rest somewhere where mine doesn't? It's not because they're misinterpreting, it's because they're more comfortable with an explanation than I am. And if I say to myself, well, I'm comfortable because I followed the data, I'm being lazy, I'm being judgmental, and actually, I'm probably no more correct than anyone else is. How on earth can you solve that? You can only solve it by being literate, but also by being deeply collaborative. The answers, the direction forward is actually going to be found not in some perfect analysis, but in some very imperfect argument and conclusion that you come to as an organization, as a community of users, as a community of practice, not as some sort of perfect analytic. So that's the world of the new analyst. Yeah, she probably still uses a Rolodex because it's more reliable than the Mac. But in the long run, she also needs to be deeply collaborative, literate, open-minded, aware, and adaptable. And that's really what I wanted to say to you today. And thank you for your attention. It's been fantastic to be back here. And I hope you have a great time for the rest of the conference, what remains. Thank you very much.